Okay, so this model that I've been talking about for the project is what's called the SIR model, which basically says this. It says we have susceptible individuals. These are individuals who do not have immunity to whatever virus, disease, whatever we may have. We have infected people. And infected, we could say infected people, but really it's infectious people. Because people can be infected longer than when they are actually contagious. Right? We hear this sometimes, you know, well, once chicken pox, once you see the chicken pox, you know, after 2 days the kid's no longer contagious, etc. So we're interested in the time during which they are in that infected stage where they are infectious. And then these are the recovered people. And recovered people, well, that just means they can't be infected anymore, so we don't have to worry about them getting sick anymore. There are two types of recovered people: those that get immunity, they have antibodies in the blood and get immunity; those that die. Those are both considered recovered cases. In our model, recovered doesn't mean you got better. Recovered means you can no longer catch the disease. And if you're dead, you can't catch the disease. And if you have recovered, you can't catch the disease. But also, recovered just means you're no longer part of the infectious group. So you're either in one of these three groups. You are possible that you will get the infection. Once you get the infection, you will then at some point move out of being in the infected case and you'll be part of the recovered case and not be able to get the infection again. And because of the fact that those three terms are all defined that way, you have to be in one of those three groups. And as a result, S plus I plus R would equal the total population, whatever that is. Now in this paper that I've sent you, what they did is they said, now wait a minute, let's just scale this. Let's divide by the population, whatever that population may be. And once we divide by the population, we're not going to call this big S anymore, we're going to call it small s of t. And we're going to call it small I of t. We're going to call it small r of t. And with each one of those, since we divide by population, will be 1 over here. With each one of those, what we are talking about is, you know, a decimal. Okay, so you know this initially this will be 100%, so this will be a decimal of 1. This will be a very, very small number. You know, you say there's 1 infected out of 8 million people or whatever. You're basically still at 0, but it's a non-zero term, and R is then the number that recovered. Now, if we look at this, then if we take the derivative of this with respect to t, we get this. Okay. So one of the first things that I want to look at here is, okay, that value right there that comes directly out of this model being the SIR model, that's important, and that'll come back to us later.